Hello, my name is Zachary Copeland. This is my first video, and this channel is going to be about programming, but it's going to be a little different. So instead of teaching you how to code, I'm going to assume that you have basic knowledge of programming, at least on the front end, and I'm going to talk to you about the back end of how code works and other interesting things about code. Like at some point, I plan on talking about the history of programming and other things like that. But today, what we're going to talk about is bit adding, and we're going to work our way towards unsigned and signed integers. Now, it seems like kind of a weird thing to go together, but it'll make sense. So let's start with bit adding, which is in its own right kind of unintuitive. So what we're going to do is we're going to start with a byte. For those of you who do not know, a byte is 8 bits. And what we're going to do is we're going to start by saying what each of these bits represents. So this first one is 2 to the power of 0. The second one is 2 to the power of 1. 2 to the power of 2, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. Now this last one, this 2 to the 7th, it can either be 2 to the 7th or it can be a sign, depending on if you're using signed or unsigned integer representation. So we'll get to that later. We're going to start with bit adding. So if we want the number 3, pretty easy number, then we start with 1 here to 0, 1, and then we add 2 to the first power is 2. And then what happens if we want 4? So we're going to add 1. So when you add 1, this one goes to 0 and it carries over, and this one goes to 0, and then this becomes 1. And then if we add 1 again, this 0 becomes a 1, and we have 5. So those are the basics of adding bits together. And the reason this ties into signed and unsigned integers is because if you imagine we have a new completely blank byte, and we have it full of ones. So that is 8 ones, which will give us 255. So what happens if we add 1 to that? Well, I can go and tell you that it's probably not ideal if you need numbers to be consistent and behave consistently in your program. So what's going to happen is we add 1, and like our last example, this first one's going to go to 0. It's going to carry over. This one's going to go to 0. 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 All the way down the line. And then 1, right? Unfortunately not. There's nowhere for that 1 to go because we only have 8 bits available to us. So the carryover stops and the bit just falls off into the ether. Pretty unfortunate, right? I think so. It's kind of sad when something that started off its life being big old 255 becomes nothing. It is now 0. So this is something you have to look out for when you are programming. It can have some very undesirable results. So I'm going to switch us over to some code that I wrote earlier. And if we look at the code right here, we have the max of an int variable type. Now an int variable type, and this is a signed int variable type, has a maximum positive range of 2,147,483,647. That is a huge number. To give you an idea of how big that number is, you're not going to live for that many seconds. Hate to say it, but you're just not. Now, on the negative end, it can go all the way as small as negative 2,147,483,648. So there's one more number on the negative end than there is on the positive end. And it seems kind of weird, but there's a reason for that. So with signed integers, when you have too many bits and you have a bit overflow, that last one just falls off. Well, in this case, it doesn't just fall off. You're at the max range here. However, there is an extra bit at the end for the sign. So let's go ahead and run this. So if we look at the first output int at max range, it's some very large number that I'm not repeating. But if we look at the binary representation for it, it's not using all of the bits to represent that number. And that is because, as I said, the first bit is used to represent the sign. So you're at the max range, but if you add 1, it should just get bigger, right? Well, no. It's going to carry all the way over, zero out everything except for that very first bit used for the sign. And as you can see, the binary is a 1 followed by 31 zeros. But the number is the smallest, or the small end of the range that an integer can get. It's negative 2,147,483,648. It's kind of odd that if you add 1 to some very large number, you can end up having a very small negative number. And then if you add 1 again, well, you're just adding 1 at this point. But are you really adding 1? That's a trick question. Yes, you are really adding 1. So we're going to go back to our little paint program, and we're going to look at this. So let's draw out another byte. Now, before we do that, actually, so a signed byte, I apologize for my atrocious handwriting, by the way, goes from 0 to 255, while a signed byte goes from negative 128 to 127. So it's kind of an odd range. So let's draw out our byte. where this first bit is the sign, so positive or negative, where positive is represented as a 0 and negative is represented as a 1. So let's fill this guy up all the way to the top, except for this first bit. I'm going to leave a 0 here. So this gives us 127. But if we add 1, all of these guys become zeros. Except this one. We have a bit to carry over to. Becomes 1, and now all of a sudden we have negative 128. And then if we add another 1, we have negative 127. So this is odd for a couple of reasons. We start at 127, and then we add 1, and it's equal to negative 128. I mean, that just can't be right. Well, this all results from the way integers are interpreted in binary. So signed integers have their range from, and we're going to stick with bytes for this for the sake of brevity, from negative 128 to 127. So if we start at 128 and we have our lovely little 1 followed by 7 zeros, okay, and we add 1 to this, which is actually just adding 1. We're going negative 128 to negative 127. And we keep going until we get all the way to here. What do you think that number is going to be? Well, spoiler alert, it's going to be negative 1. So if this were an unsigned byte, it would be 255. So if we add 1 more and we get all zeros, then we have 0. And it goes all the way up again. Add 1, will be 1, 2, 3, all the way up to 127. So when you have these signed integers, the way they represent negative numbers is interesting. Instead of starting at 0 and subtracting like you would intuitively if you learned math anywhere inside of the US, really, you start at the smallest possible number and you start adding. So it's just the way it's interpreted. This is the smallest number you can have. And this is the largest number you can have. And because of the way that they're interpreted by your computer, if you have the largest number and add anything to it, you end up wrapping back around because of bit carryover and going into the negative. It's a little bit strange, but they had to come up with a solution somehow, and the best way they thought of was to start at 0 and go up, and then start going into the negatives so we could keep this leading bit as the sign. But anyways, that's all I wanted to tell you about, and I hope you're having a lovely evening, if it is evening when you're watching this. And good luck programming, and hopefully this will spark some interest into learning why some of the weird behaviors code has are there. And have a wonderful night, and I will update later.